Okay, so this is the answer for page 179, question 2. They are asking you to define an acid in terms of the Bronsted-Lowry theory. Remember, there are two theories, Arrhenius and Bronsted-Lowry. Bronsted-Lowry always makes reference to protons. So here they are asking you about the behavior of a proton for an acid. So your answer in this particular case would make reference to how a proton behaves when you deal with an acid. And when you're dealing with an acid is a proton donor. Right. For 2 marks, but basically you have to put it in a sentence would be beneficial, but I don't see anything wrong with this particular answer as you leaving it just as it is. The next question asks you to consider the reaction below, and it's hydrogen fluoride or hydrofluoric acid plus water produces a hydronium ion plus the fluoride ion, as we can see over there. So they ask you to write down the formulae of the conjugate acid-base pairs in the above reaction. So please remember the order is acid, base. So you write the acid first and then you write the base. So if we're having a look there, let's identify first of all our conjugate pairs. So in terms of our conjugate pair, here we've got hydrogen fluoride and the fluoride ion. Remember, this is our acid because an acid contains a proton. So on the opposite side, we need it not to contain a proton. All right, so when you remove the hydrogen, all you're left with is fluoride. And obviously, if you're an acid on the reactant side, you will be the conjugate base on the product side. Then obviously, the only thing that is leaving us with is our water and our hydronium ion. Now again, from the previous question when they asked you to define what is a Bronsted-Lowry acid, that means that information, what is a Bronsted-Lowry acid? A proton donor. That information is necessary for the next question. So the one who is a proton donor is the acid. So whoever has an additional proton becomes the acid. And then obviously if you remove that proton, you are a base. That is one way of looking at it. The other way that you can look at it is you can identify, if I've already identified one as the acid, then the other one must be the base because it's always as a pair. And then over here, because you've identified the base already, you then obviously realize that the other one can only be an acid. So now all that's left is for us to write down our answer in the form acid and then base. So your first one, your acid is hydrogen fluoride, and your base is going to therefore be your fluoride ion. Please, I have written the charge. Can you all see this charge here? Do not forget to write the charge. It is important. The next one I'm going to do is your conjugate acid-base. So acid first. So here when it comes to my water and my hydronium ion, because my hydronium ion is my acid, I will start with my acid. Again, you can see I'm writing the charge and then water. Okay, so there you can see I've written them as a pair. As you can see, one is from the reactant, one is from the product. One is from the reactant, one is from the product. You will have a pair being one from the left-hand side and one from the right-hand side. A pair does not exist on the same side. Are we clear? Then the next question, they say write down the name, and as you can see it is in capitals, meaning it's important. Write down the name of the substance that can act as an ampholyte in the above reaction. An ampholyte, what is the definition of an ampholyte? A substance that can either be an acid or it can be a base. Always remember that when you are answering these very simple questions, don't just get caught up in not paying attention. An ampholyte acts as both an acid and a base. So if we look at hydrogen fluoride, it is only an acid. We cannot put another hydrogen there. You will not get a substance that exists like this. This cannot exist. So since it cannot act as a base, meaning we can add another proton, this is not our amphiolite. Here, if we're looking here, it is a base, okay? If it was to be an acid, it would have to be able to donate a proton. It cannot donate a proton, so therefore it cannot act as both an acid and a base. Here, the substance is acting as an acid. In order for it to act as a base, it would need to be able to accept a proton. This substance, to accept a proton, does not exist. Okay? This substance does not exist. So the only substance we are left by process of elimination is water, and you should know that water is your major component. Now, this, what I've written here, will be marked wrong. Why? Because the answer has to be the name. And the name of H2O is water. So please keep in mind all of that information. And then the last question, they say sulfuric acid, oh good grief, is a strong acid. And they ask you to explain why sulfuric acid is considered a strong acid. A strong acid is a substance or an acid that ionizes completely in water. But the in water part is not necessary, but we would want to put that in. It ionizes completely in water. That is what a strong acid is. And the key word here is completely. So if you just say it ionizes in water, that is not the definition of a strong acid. So now the last question is to calculate the pH of a 0.025 mole per decimeter cube sulfuric acid solution. Please be aware that when you're asked for calculations, it is imperative that you start with step 1. So step 1, identify your variables. 0.025 mole per decimeter cubed of sulfuric acid. Mole per decimeter cubed, you can shorten it if you want to the SI unit, just mole. All right. Step 2. That's all the information they've given you. Step 2 would be to identify a formula. Now, there is no formula that we have in existence that only uses concentration. Right? This is the concentration only. All other formulae will have another variable. So, we need to ask ourselves, if we cannot find a formula, let us look for a ratio. So this is just additional now on top of what you've previously done when it comes to step 2. A ratio is also a formula. So if we cannot identify a formula from the formula sheet, the next best thing that we can think about is a ratio, because a ratio will link two pieces of information together. So if I look at an acid, here's my acid, what information does my acid relate to? The only thing the acid relates to is the concentration of hydronium ions. There's the concentration of hydronium ions. And if you pay attention here, sulfuric acid is a diprotic acid, meaning that for every one sulfuric acid molecules, I will have 2 hydronium ions. So I have a ratio. This ratio can be used for number of moles as well as for concentration. As you can see, they have indicated square brackets, meaning that I'm looking more specifically at concentration. So if I know the concentration of sulfuric acid is 0.025, that must mean that the concentration of hydronium ions is 0.50 molar. Are we clear? Does that make sense to you? The ratio is 1:2. So all you have to do is multiply this by 2. Stick that in your calculator. You multiply it by 2, and that is the answer that... Oh, no, good grief. That is not the answer that you get. No, we are right here. You multiply it by 2. This is not 0.05. This is 0.050. 0.05. Right. Sorry about that. Forgot the zeros there. Just checking if you are awake. So you just double check that on your calculator if you don't believe me. And that is the answer that we get. So now I have step 1. Still in step 1, hey? Because we can't go to step 3. That is now where you're substituting. So still in step 1. Now what information do I have? I have the concentration, mole per decimeter cubed, of sulfuric acid. And I have the concentration now of my hydronium ions. So this is the information that I have, the concentration of my hydronium. This is the only new information that I have. So I go to step 2 now, because remember the idea here is to look for a formula. Now with the formula that I have, if I've got a concentration of hydronium ions, this is the formula that looks at concentration of hydronium ions. There we go. And now I can do step 3, which is substitution. So pH. Now keep in mind in your step 1 initially over here that you also need to identify the variable you're looking for. So not only do you have your concentration of your sulfuric acid, but they're asking you, the question says, what is the pH? So this is what we are looking for pH. Right, and there was no formula that looked at concentration of sulfuric acid and pH. That is why we had to go to a ratio. After we went to the ratio, now we've got a new value, which is 0.05, and that is our concentration of our hydronium ions. So our step 1 has now been expanded, but we still need to identify what is our pH. So in our step 2, when we are picking our formula, this value here, we have used it already. This value we have yet to use, and this is what we are trying to find. And so there is the formula that is going to meet our requirements. Now when it comes to answering of your question, you substitute negative log, and your concentration is 0.05, and stick that in your calculator. So you're going to say negative log 0.05, and your answer is 1.3. You know, the 1.30 if you want to. pH has no SI unit, it is a constant. So there I have already done step 4, which is answering my questions. If you have any misunderstandings or you need clarity on anything, please contact me with a specific question. Thank you and good luck.